Testing. Testing mic 1 2 3. If you can hear me, that's right there in the chat. Yes. And for the student, can you just test out the mic, your mic, so that I can hear you? Okay, thank you, Jane. Thank you, Jen.
Hello, Doctor. Can you hear me?
All right. Okay, I can hear you. I'm reading it. All right. Thank you very much. I'm going to share my screen. Yeah. Assalamualaikum. Very good morning. So I'm going to start class. We are already. So okay, before we start, as usual, please go to Learn, okay, and click on attendance. Okay, this will be the normal routine for our class. So go to you can just directly go to week 5 and then go through what are the lessons that we're going to go through for today. So normally lesson 5, we have the linear outcome for today, and then we have 5.1, which is on the. So just go there and click on attendance. Okay. By now, it should be okay. 5.2 is our class today, this morning, synchronous class, and we also have activities later on at that. Okay, and lastly will be on the reflection. So after class, normally I will open it after class. So at 10, until note today, students need to actually give a feedback on the class today. Okay, so what we have learned, elaborate. If you elaborate more, then I know that you attended the class. If it's short, only 5 words, then it means that, or you copy paste from the notes, or even for the linear account, then I know that you did it. And well, just copy and paste. Okay, so please do follow the lessons. 5.1 and 5.4, and for today, I'm giving a bit of tasks. So normally what I saw is that I asked students to upload their activities, their answers in Padlet. But in Padlet, for some reason, not all students upload their answer. So I'm not sure if they actually did the question or not. Example, this Thursday, week 4, okay? So I think roughly about only 10 students answer this week 4 on Thursday. And also for homework, this one I didn't ask students, but it's in the Padlet. So if you saw there's a task or exercise, then please do it. And it's not compulsory, just that I mentioned here is that exercise and homework, do this to score grade A for subject. Okay, so means that those students who actually did the task, then I'm sure they will be able to answer the subject, chapter 1. Okay, and do not actually copy your friend's answer. Please answer on your own, because later in midterm and final exam, we're not going to copy your friend's answer. You need to elaborate on your own. So this is like the trust between the lecturer and student. So I trust you that you do it on your own and you do not copy your friends. Okay, if you copy your friend, actually it reflects in your midterm and final exam. Then the grades, basically. Okay, I will know that students who get bad grades is that they actually didn't do any homework but copy. This is unfortunate for students. Do not take it simple. Make sure that you do the best, not only for this subject but other subject. Okay, and for in the Padlet, I already uploaded for this week. Today is that we have 2 activity. So later on, when we go along, as we go along with the topic, then we will have some activity. Okay, everybody in. So I see that there's 31 participants, so I'm going to start now. So for today is that we're going to continue for chapter 2. Okay, chapter 2. We are a bit late according to the teaching plan. Actually, chapter 2 we need to start last week, week 4. But anyway, I would confident that we can finish chapter 2 by next week. So this for today is that we are going to cover for the discrete time, for the LTI system, and for next week we'll be covering for the continuous time system. Okay, and announcement. Okay, announcement to all students. This one I have also announced in the Telegram. So the midterm exam will be held on the 17th May 2021. So it's on Monday. It's basically at week 10. Myself as a coordinator and also two other lecturers, we already discussed among ourselves. So since a lot of students, as you can see, a lot of students are joining taking this subject. So they are BETM and BEKC student, and all some the majority is from second year, but they are third year and fourth year. So therefore, we finalized that the midterm exam will be on week 10 on Monday, 17 May 2021. So make sure that I hope that, because since nobody actually replied that they have anything clash and so on, so it's confirmed that we have a midterm on 17 May 2021. Okay, so make sure that, and it's on at night, 9 p.m. and when you will be online, I will inform later on through what method, but my plan is that it's going to be through my ULEN. Okay, ULEN for section 1. So all of the students, section 2 and 3, which is section 3 is for the BEKC student, are going to join my ULEN. And because since I already sorted you guys according to section, so it should be no problem. So and the chapter that we cover is chapter 1 and 2. Okay, so basically those who already joined my class since week 1 and week 2, week 1 until week 4, and you already submit some activities, right? Activity week 1 to week 4, and also the feedback form. And from there, actually, I know that you are actually under section 1. Okay, so those students who actually didn't give feedback and also the task, then I will remove them from section 1. Okay, so this is the effect. So if you do not attend my class, do a feedback form and pass. But I'm sure everybody actually submitted. Okay. If you don't submit, then you need to send me an official email why you didn't join my class, do the activity, and do the feedback. Right? And it must be a very good reason. It's not because you didn't wake up, so on. Okay, that's not an excuse. Yeah. Okay, so we are going to continue. For this week, which is on chapter 2. We have 4 main topics that we are going to cover, which is the definition of LTI system, linear time invariant system, and actually I have also we actually covered this. I covered this in the properties of the signal system in chapter 1, which is the last topic in chapter 1. There were definition of LTI system. Okay, so this is where we are going to go through the whole thing. And secondly is that on the discrete time, LTI is linear time invariant system. So for this discrete time LTI system, we call it as the convolution sum. Okay, so later on we are going to go through. For today is on the convolution sum, and next will be on the continuous time LTI system, which is we call it as a convolution integral. So one is summation and one is integration. Okay, so if, as you can see, one is much more difficult from the other. So convolution integral will be a bit difficult from the convolution sum. That's why I'm going to start with the LTI invariant system for the discrete time first, so that you understand the concept. So after understanding the concept, then you can actually simply apply it to the continuous time system. And lastly is on the property of LTI system. Right? So let's see what's the definition of linear time invariant system. So so what is LTI system? So LTI system is a combination of linearity and time invariant. So which by combining these two methods, it will make the system analysis easier. Okay. So LTI system can be represented as a linear combination of delay impulses. So as you have seen in chapter 1, okay, chapter 1 and chapter 1 is for discrete time and continuous time. You have learned that a system can be represented as a step input, impulse input, and so on. So for LTI system is that it actually explains that it can be represented as a linear combination of delay impulses. Right? So for that based on that definition is that, okay, if you can combine combination of delay impulses, okay, plus superposition plus time invariant, then you can actually use these three methods to actually calculate for discrete time using convolution sum. Okay, so first one will be on convolution sum. So convolution sum is using the combination of delay pulses, superposition, and time invariance. Okay, similarly to convolution integral, which is used for the continuous time system, then you also have these three methods combined. Yeah? So what the basic system property for an LTI system is that we have the time invariant and the linearity. So what was it? So this one is based on in chapter 1 property. Okay, if you see chapter 1 property, I have explained that time invariant system, a system is called time invariant if a time shift delay or advance the input signal causes time shift in the output signal. So anything that is shifted in the input will give us same shifting in the output. So for that case alone is that time invariant can be written as this signal. This one will be written for the continuous time signal, and for the discrete time is going to be written as this value. Okay. And the difference is that if you see here is that for tau is for any real value and k is for any integral. Okay, so later on k is the one that we are going to shift at. And remember, and the second one is linearity. So for linearity is that we have the two property. We have the additive property, and then we have the scaling property. So additive property and scaling property, we actually have proven in one. So by having this combining two property is that you can have the superposition property. Okay, so let's go to the first one, which is on the discrete time LTI system. So I would say that chapter 2 will be comprised of a lot of mathematics, okay, mathematics, graph, sketching, and so on. So make sure that you have a piece of paper in front of you, okay, and a pen or pencil. Okay, so and I would suggest for this subject as a system, buy a book that is have square line. I mean the square line, like the mathematics book, the school book. So you can buy that one. So it's easy for you later on to draw graph and so on. You have already line there. So we are going to look at the discrete time LTI system. So using the linearity and time invariant to obtain the compact characterization of discrete time LTI. So example, you can actually transform or express the transformation. Any shifting in the input will give a shifting in the output yn. Okay, so it can be observed that any signal can be composed as superposition of time shift unit impulses. Okay, this one is just a theory. Okay, we are going to go into the equation and also the graph example. So you see here a sampling or shifting property of the impulse. So we can see that for the discrete time signals is shown as a sequence of individual impulses. As you know, continuous time signal are represented as these pulses, like example pulses. Okay, and so on. So this is what we call as this one, discrete time signal as a sequence of individual pulses. So and for the discrete time is that you have the defined input is given by this xn, okay, is equivalent to the summation of xk delta n minus k. Right? So what does it mean here? Okay, what does it mean by this equation? So let's just prove it. Okay, so example 1 here. Okay, observe that you have xn. This is a signal xn. Okay, it is a decomposition of a discrete time signal into a weighted sum of shifted impulses. Okay? So if you look at this signal, okay, let's look at how many pulses do we have here? Right there in the chat, how many pulses that you can see? How many impulses that you can see in this signal? Right there, what are the value? D, Jurgen, none. Okay, the rest? How about the rest? Tan Zihui, 6. Muhammad Rizwan, 3. Who else? Are we there? Yu Jun, 3. Yeah, 6. Amidin, 6. Okay, so the correct answer is 3. Okay, why? Okay, remember is that this one is a signal. Then let's assume that this signal is 1, this is 2, and this is 3. This one is signal at 0, right? So 0. Actually, you have 0 until infinity over here. And also you have 0 until infinity. So the total number of impulse that you have here is only 1, 2, and 3. So you have only 3 impulses. Okay. So by having that value, okay, so let's write the equation here. So you have xn summation of c delta n is 1 and minus k. Okay, so let's look at the first impulse. Okay, how to answer this question is that by it's normal for signal, we look at from left to right. From left side, this is your eye. Okay, okay, look at this side. So what value do you see first? You will see that you have a n value or the n value at -1. So you have actually x minus 1. Okay, you have x, the value for that k value is what? Is minus 1 delta n minus, okay, this k value is -1 minus -1 plus 1. Okay, so that is where you will actually get this signal. Okay, so my x minus 1 is actually represented by 0 minus 1. Okay, we have a delta n minus 1, so it's at this value 2. Okay, the next signal that you see here is at x0. So we have x0 delta n. Okay, so meaning that the n value is actually no shifting, kan? So at 0 lah. So another one will be at 0, and you have the value is 1. Okay, and the last one is x1, x1 delta n minus 1. Okay, n minus, and because you have the value of k is 1, so minus 1. Okay, so you know that x n minus 1 is a time delay. Okay, time delay to the left shifting, and you have the value is 3 over here. Actually, how do you write this is that this x minus 1 is represented by the amplitude 2 over here. Okay, then this one x0 is represented by 1 here. And then x1 is represented by the width, which is 2. So if you were to write this back, then you can actually write it as 2 delta n plus 1. Okay, then you have delta n, then another one we have 3 delta n plus 1. Okay, so this is how you actually prove the definition of the input just now, this equation. Okay, so looking back at this equation, okay, and you can see that you actually have the summation. Summation of xk, this one x minus 1 plus x0 plus x1. So that is why you actually get the value of these 3 signal combined. So actually you can write here as this signal number 1, signal number 2, signal number 3. You actually add it up. Okay, then you will get the x and the signal. Okay, and remember, chapter 1 and chapter 2 is related. Okay, you can see that this one is what we have done in chapter 1. We have the shifting, okay, time advance, time shifting over here. We have the time delay or time advance, and plus 1, minus 1. And then you also have the time scaling. So this one is scaled by 2, this is 1, and this is by 3. Okay, so remember, whatever, if you don't understand chapter 1, it will actually implicate you in later on in chapter 2. So make sure that chapter 1 you really understood about topic. Okay, if chapter 1 you confused with a few things on how to draw the graph, the method 1, 2, then it will actually implicate you later on. Okay. Now we go to example, this one is exactly similar. So what I explained just now is actually, this is the same thing. So I'm going to skip that. Now we go to the convolution sum. So convolution sum is the LTI, how you actually calculate for LTI system for the discrete time signal. So remember that in chapter 1, we have learned about something look like this, a block diagram. You have an input, okay, you have an output, you have input, you have output. But remember, last time in chapter 1, what I showed to you is that you have the input here, xn, example, you have a signal, then you have yn. Okay, but the block diagram inside is actually not a signal, it's actually a gain value. Remember, you have 2 examples. 4, so you have a scaling and so on. Okay, so for this chapter 2 is that instead of having this value of k, you have a impulse response function, or you have a signal, a waveform. So you are given by hn value, or we call it as a system. Okay, so why we call it a system is that normally in control or subject, when you have a block diagram, the block represents a system. Okay, so a system can be a signal, an equation, and so on. So in the case of a system, is that the system is represented by a waveform. So for the case of for the convolution sum is that we are going to use 2 types of property. Okay, the first one will be the linearity property. Okay, So linearity property would be on the scaling properties. Okay, you have already defined the input in the previous slide just now. So now we are going to define what are the output. Okay, so output is given by y and equivalent to summation of xk hk. So just the scaling property of that. So just to actually write out the equation for this block diagram. So if you are given an input xn, this one is xn, okay, and you are given a block diagram like this, which is the system impulse system here. The system is given by impulse response. Then you can actually write out the output of this block as given yn equivalent to summation of xk hk. Okay, hk is this one of the system. Okay, and the second property that you are going to use inside this temporary system is that you're going to use the time shifting. Okay, so after you have defined what are the output equation yn equivalent to summation of xk hk, and then you can actually write out the equation for convolution sum. Okay, convolution sum. Convolution sum is given by yn summation of xk. How you actually represent this value of hkn is by having a shifting value. Okay, so it's going to have a shifting value hn minus q. So in this topic, we are going to learn how to do the convolution sum of today. Okay? And the symbolic representation of the convolution sum is given by this equation. So if in a question, okay, you're given this block, okay, find the output yn, right? For open book type of question, the question will not be a guided question. Means that we're not going to mention what type of equation to use. Either you use convolution sum or convolution integral. Okay, if you know that it's a discrete time, how do you know that it's a discrete time system? You have this value is actually written as square bracket, and so you know directly that's a you know that it's actually a discrete time system. So when you know that, then automatically if it asks you to answer, okay, what calculate for the signal for yn, okay? And you know that you see that in the inside here the system is actually a signal, okay, not value integer value. It's a signal, means that you have a waveform. So automatically you know it's basically you need to use the method in chapter 2, which is convolution sum. Okay, so for convolution sum, the equation is given by this, okay, and represented the symbolic of it is by written as yn equivalent to xn star. Okay, star is the symbolic hn. So actually I can write here yn equivalent to xn, okay, star hn. So this is, if you write here star, then I know you're going to write it as a convolution, and it's a sum because of the discrete time. And if you are feeling great, you can actually use this equation. So I can write this equation, then I want to elaborate more, I can use summation from minus infinity to infinity, xk h and minus k. Okay, so this one will be the equation for convolution. Now we go to let's look at the method to actually calculate for convolution sum. Actually there are two methods, but the normal method that we propose students to use this method too, because will actually we are going to draw out the graphical interpretation of the convolution sum. For method 1 is that it's solely based on equation. So if you write it wrong, the equation, then you will get the wrong output or wrong graph. Okay, so solely for just to compare the difference between method 1 and method 2, I'm going to teach you two methods. But in exam, you're going to use the graphical interpretation of the convolution sum. Okay? So let's look at method number 1. So method number 1 is that you already learned that we have the equation. We have the equation yn can be written as xn star hn, or because you know that when you multiply something, okay, you can actually write it in a vice versa. So you can actually use yn equivalent to hn first star xn. So these are the two ideas how you can actually write the convolution operation. And then I already explained that it actually represents this equation. Okay, so here is that. Okay, you can see that the first equation here is represented here. Okay, so yn xn star hn. So we start with xn first. So yn equivalent to summation of minus infinity to infinity. This one. Okay. So yn hn. So we start with hn. So hn is summation of hn, and then we have xn minus k. So this is one way how to write it out. Or if you plan to use this equation above, so you can write it as yn equivalent to xn value here, xn, hn minus k. Okay, so these are the two equations that you can use. Either one. The y, you can actually interchange it. Okay, it depends on the signal. Okay, given later on, you will see why sometimes you want to use this equation, or sometimes you want to use the second equation. It depends on the signal complexity. Okay, normally we are going to shift the signal that is easier. Okay, this one I will explain later. And for method number 2, there is a procedure. Okay, procedure. So we have four procedure. So the procedure number 1 is that, okay, impulse response HK. Okay, you know that we have HK, and then HN and SN, and normally we want to find what is YN. So impulse response, just now the HN value, okay, you are going to change it to HK. Okay, so change it to K is time reverse reflected at origin. So originally you have HN, then you change it to HK. So N, change it to K value. Okay? And then you're going to reflect it at origin, means that you are going to do a time scaling. So time reversal. So from HK is going to be H minus K. So just add a minus here. Okay. So step is HN, then HK, then H minus K. Okay. Remember, this is graphical interpretation. So it means that we're going to draw out the graph. This on the graph for HN value. Okay. And then number 2 is that shifting H minus K, which is shifting whatever that you have, you get the last graph over here by N to form N, H, N minus K. Okay. So meaning that you're going to shift everything and then to form H, N minus K. So if you see here, it's actually representing this equation, H, N minus K. Okay. Next, the two sequence xk, okay, xk, which is this one, okay, and h and minus k are multiplied together for all value of a with n fixed at the value. So this one will be the tricky part. Okay, 1 and 2 is easy. The third one will be a tricky part. Okay, so this one, please focus on that method later on. And last is that product of xk times h and minus k is summed over all okay, to produce a single output. Why? According to the equation, the product are sum over because you have the summation over here. So this method 2 actually from step 1 until step 4 represent the equation over here. Okay. Maybe it's a bit confusing, but okay, we are going to do an example. Example 2, just now we already did example 1. So example number 2. Okay. So consider an LTI system with the impulse response Hn. So you have Hn value and input Xn. Okay. Find the convolution sum Yn and sketch the output of the system. Okay. In this example is that it states that you need to use convolution sum. Okay. But in an exam later on, open book style, is that we are not going to actually guide you. Okay, you will actually consider an analytic system with impulse response Hn and Xn. You are given Hn and Xn. Find Yn and sketch the output of the system. Okay, so see the difference between these two questions. Okay, one is that it's guided. Okay, for close and for face-to-face exam, like normal face-to-face exam, because student need some guides and so on. So we guide student to use whatever. But for open book, since you can refer to any notes, videos, whatever and so on, yeah. So that is not going to be kind of question. So you need to know what method to use. It means that you understand what method to use. Is it convolution sum or integral? Sometimes if student read this question, okay, they read this question, Hn, Xn. Some student is still confused. Is this a continuous time signal or a discrete time signal? They're still confused. Reason why I say they are confused because they answered this question using convolution integral. Convolution integral is used for continuous time. So this is the lecturer can actually evaluate that we understood or not what the topic. So should be you can very fast know that this is going to be using the convolution sum because it's a discrete time. Why discrete time? You see that there's an n value, square bracket n, square bracket n. Even the Yn is a square bracket. 3 here, square bracket 3 times. Okay, then it should be a discrete time, which is convolution sum. Okay? So this one I found that lots of students still make mistakes based on my previous experience teaching this subject. Few batches already. Still, students are confused between discrete time and continuous time. Okay, so make sure that you understood it already in chapter 1. And for those who missed chapter 1, then you're missing. You're missing the advantage there. Okay, so please go through again the notes and the video and go through this the class. Okay, that is one thing. Okay, so now we are going to find the convolution sum for this question. So Yn, you're given Hn value. Okay, you have n value here. Okay, it's given by you have a value at 0, 1, and 2 with amplitude 1, and then for Xn is that you have a value at 0 and 1, and the value is 0.5 and 2. Okay, so let's look to the first method over here. The first method is by using the equation. Okay? Using the equation. So by using the equation, how to solve this equation is that look at the equation over here. Okay, equation. So how to solve this is that first one is that you need to find the non-zero value. Okay, at Xn value or non-zero. It's either two ways, like either you want to find this value at Hn or Xn. let's say that we are going to use, okay, originally, if you see here, we normally we have xn summation xk h and minus k. The one that we are going to shift is the impulse response. So we try to use this value first, okay, this equation. Of course, you can try also using this one later on your own. I'm going to teach you how to use this equation to actually prove it. So first is that find the non-zero value, okay, at xn. So what is the non-zero value at xn? At x, for n, at what value? Somebody answer in the chat. What is the value at n here? We are going to refer to xn. So what is the value that is non-zero? Non-zero value for xn is at n equal to what? N at, what is the value? And here is what's the value? K, because we are referring to this equation. So K is at 0 and 1, okay, correct? Okay, why? So look at this xn. Okay, look at here, open your eyes, look at this position. So what are the value that you have an amplitude value other than 0? You have at 0 and 1. So therefore you have a 0 and 1. Okay, so very good, Kia. Okay, so based on that, you need to write out the equation. So you have x0 is amplitude is 0.5. Okay, and you have x1 is 2. So write that out. Okay. Next is that by having this value, okay, then you are going to use the equation. The equation is yn equivalent to summation of xk h and minus. So remember that we are using the k value over here. So it means that this one is actually xk. Okay, xk. So by having that as actually you already found out what are you already fill in the first part of the equation, xk. Now we are going to look at h and minus k. So write it up. Okay, so we start with x. Based on that xk, we have the non-zero value. So we can write it as x0 h n minus k. At k equal to 0, then n minus 0 lah. So you can write there as h n. So okay. Okay. Plus what else? We have x1, right? So x1. Okay, h n minus 1. Okay. So if you were to substitute the value, you already know what is x0. Here, and you already know what is x1. Where is it? We have here. So you can actually rewrite that as 0.5 ish plus x1 is 2 ish and minus 1. Okay, so oh sorry, from this equation alone, okay, you're going to draw out this one, 0.5 HN. So can somebody answer in the chat? Answer, not somebody, like everybody, answer in the chat. For the first equation, 0.5 HN, what are the transformation properties? In chapter 1, you learn about the properties, transformation properties. So what is it? 0.5 HN, what properties? Amplitude scaling. Okay, correct, Natasha. Okay, so how about the second one? This second equation, 2HN minus 1. Where is everybody? Yang jawab seorang. Okay, Nurul Natasha lagi. Okay, so the second one is time shifting, which is delay, and amplitude scaling. So very good. Okay, so based on that, if you understood that, so you can actually draw out. Okay, so we are going to draw out 0.5 HN. So HN is this signal above here. So you have 0, 1, 2. Okay, and amplitude here is time scaling is 0.5. So you have here, because you have 1, then you have all of the amplitude is 0.5. Okay, and then second one is that you have the signal. You have 2. This one is 0.5 HN. Another one is 2 HN minus 1. So we are going to do that. Are you going to do time shifting or scaling first? Time shifting or scaling? Where is the other student? Hello guys, are you actually available? Who's that?
Time shift.
Time shift. Okay, time shift first, Right, thank you. So you're going to do time shift by 1, So shifting by 1. So shift it to the right by 1. And then you have the amplitude 2. So meaning that it's going to be divided by 2, So we have 0.5, 0.5, 0.5. Sorry, not 0.5, it's amplitude, amplitude shifting. So amplitude shifting is that you multiply it. So you have 2, 2, 2. Okay. So this one is actually your yn value. So yn value, you are going to write out the graph. Okay. So you have 0, 1, 2, 3. And based on this, you can see that it is actually signal 1 plus signal 2. So that's why you have the first signal plus second signal. So just add that up, you will have 0.5, 2.5, 2.5, then you have 2. Okay, so this one is the y. Okay, so understood? Method number 1. Okay, so imagine that It looks simple for method number 1. If you have actually very little, start here, impulses. You have little impulses. So another method that you can use using the same method 1 is that using this equation. So you have yn summation of hk x n minus k. So if you see here, what you need to do first is that if you are using this first equation is that you need to find what are the non-zero value for hk. So instead of xn, you need to find what is the non-zero value for hn. Okay? So non-zero value for hn is 0, 1, and 2. So repeat again the answer. Okay? You should get the same answer, which is yn equal to this. Any question? Anyone who blur or know the method? You can ask now for me to repeat. If everybody understood, then answer in the chat understood. Before we go to method number 2.
Understood, madam.
Okay, thank you. The rest? Yang menjawab ni okay, no problem because they are listening to me. The thing is that those who don't answer, I'm not sure if it's sleeping and so on, right? So that's why I need to confirm. Okay, so understood. Okay, very simple lah. Looks simple. Unless you get a difficult question, then it will become this method 1 will become disadvantages. So that's why normally we are going to use method number 2. Okay, so method number 2, how we are going to go about this method is that okay, method number 2 is that we're going to go using the reciprocal interpretation or using convolution sum. We have the 4 steps just now. Okay, step number 1 is that write response of hn. You will write it as h minus k. Okay, so how to write it is that follow strictly how I explain the method. Okay, if not, lost. Okay, so I'm going to write out first. We are going to use this equation. Okay, means that we are going to shift h and minus k. Similar to the first method, what we did was we shift h and minus k. So I'm going to use the same thing. We are going to shift h minus and minus k. Okay, and between these two signals, hn and xn, which one do you think is more simple? Is that it's not complex? Which one do you think is simpler?
Method 1.
No, not method 1. I mean between the signal hn and xn. Which one do you think
Hn.
hn is simpler? Okay, thank you. Because you have only amplitude 1, okay, and 0, 1, 2. So this one looks, hn is much more simple. So that is the reason why you are going to shift that signal instead of shifting xn. Okay, so by doing that is that you are going to write out the first equation. Okay, you are going to use this equation xk over here. Okay, write out xn first. So I'm going to write out xn 0, 1. You have 0.5. Then you have 2. Okay, so this one I'm going to write it here as x. Okay, so after writing that, then we go to h and minus k. So we are going to go to the first step over here for the shifting. So look at this first step. So we are going to write hk, okay, and then you're going to reverse it, reflect HK. So meaning that this one write it as HK, this one become K. Now K value for 0, 1, and 2. And then you're going to reflect it at the time reversal. Okay, so meaning that then you are going to flip it at minus K. Okay, so if I were you, I just simply write it out down here. Okay, I'm going to write it down here. For H K, I have 0, minus 1, minus 2. So automatically, I will know that I have a 0 here, minus 1, minus 2. Draw it in a parallel with this xk. Okay, draw it like this, parallel. So you have a 0 value is 1. One, one, one. Okay, 1f. Okay, so this one is the first step, and you can write out the equation here is as h. And if you see here is that you have h minus k. I'm going to write that again. This one, this 2. Okay, now second equation is that shift h minus k to form h n minus k. So this is looks difficult, but it's actually not that difficult. So what happens that you're going to add n in the front here. Okay, so meaning that this equation will become n minus 2, n minus 1, and n minus 0, or you can write it as n. Okay, so you write h n minus k as this value. So you have the part here n minus 2, n minus 1, and n. Okay, and next is that the third. Now we are done with the second part. Third one is that the two sequence xk, this one, are going to be multiplied together with h n minus k for all value of t. So remember is that you have k value here. So you're going to write here as k. Because you already convert just now k to n to k. So you are going to take it as k value. Okay, so you are going to multiply it at every every k value. So for this case is that start first with write the equation. So yn equal to summation infinity, infinity. Then you have xk h minus k. Okay, and then we start with when n equal to 0. Okay, okay, we can start with that. Okay, look at the value here. We have at 0 and 1, 0 and 1. Okay, and then you have also at n minus 2, n minus 1, and n. Okay, let's say that if you set n value is minus 1. Okay, let's say n value is minus 1, and so I'm going to write here n minus 1. Okay, so you have the value, this impulse will be at minus 1, n minus minus 1 at 0, and minus 2, you have it's 2, minus 2, and then minus 3. Okay, so can you understand how I'm writing this equation? You understand how I write this equation? So we start with n minus equal to minus 1. Okay, so I'm going to write here n equal to minus 1. So just substitute n value. So n equal to minus 1, and just now minus 1 minus 1, we have minus 2. -1, -2, we have -3. So meaning that you actually have this signal being shifted to the left side. Okay, so if we have n at -1, okay, so mean that, do you think there will be any signal is overlapping? This is 0, 1. This is at K. This is 2. And I'm going to write here at H n minus T just now. Here you have the signal at 1, 0 for this HK. But for HK value, you have it shifted already. You have at -1, -2, -3. Okay, so we have it 1, -3, 1, 1, 1. Okay, so referring to the equation just now, this equation, okay, you see that yn is equivalent to at a t value. So t and the t value is at, sorry, this is not n. Sorry. This one is at k value. So we have the k value at -1. It means that you're going to multiply these two signals. Xk times h n minus k or k at -1. Okay, so you will get actually at 1, y at -1. So if you multiply this, what is the value? There is no overlapping value. You can see that at -3, -2, -1, for xk there is no value, so you will get 0. Okay, and also for this value, we see that this one at this side is actually 0. So basically, if you multiply it, you will get 0. So at k at -1, you will have 0. So this is just to confirm that there is no value before that the k value, k at equal to 0. So right now, so the first step is that check first the signal, the multiplication of the signal xk and hk, you will get 0. So you will start with this k value, k equal to -1. Next, we go to k equal to 0. So k equal to 0, okay, we are going to write here k equal to 0. Sorry, this is k. So you have 0, -1, -2. Okay, so 0, -1, -2, I can see directly I'm not going to write out this graph anymore. I'm going to refer only to this graph. So you see here is that you have the value at hn minus k at -2, -1, and 0. Okay, and compare it with this sk. Okay, which part you have a signal there? You have at 0, right? Okay, so this is it's a shortcut lah how I show it. So right here at y equal to 0, you have x 0 times h and h 0. Okay, so you have 0.5 times 1. So you have 0.5. So you have 0.5. Next, we are going to check for k equal to 1. So k equal to 1. So again, and substitute with this is at 0, k equal to 1. Then you have n equal to 1 lah. You just follow this one. Okay. 1 minus 1, you get 0. 1 minus 2, you get -1. Okay, again, check. If right now you have this signal, you have 0, 1. So do you have a similar signal in the h minus k right now at k equal to 1? So you have this one. Okay, you have a value. So based on that, write out y 1, you will have 0 times h. So h1 h n minus 1 plus n minus 1 times n minus 1. Okay, so you have here at 0 point and then 0, so you have 1 times 0 0.1, 1 times 1 plus 1 times 2. Okay, look at here, 0 and 0, so 1 times 2, 1 times 2. So you have 0 0.5 plus. Okay, so you're going to continue. Okay, I don't have space here, so I'm going to continue down here. Okay, at k equivalent to 2. So k equal to 2. So you have n is 2, 2 minus 1, 1, 2 minus 2 is 0. So look back again, which part which is overlapping with 0 and 1. So we have this value. Okay, so you can very easily write it y2 equivalent to, okay, I'm going to eyeball it, 0 times at this point, 1 times 0 0.5, 0 0.5 plus 1 times 2. So you have 2.5. Now we are going to go to k equal to 3. K equal to 3. So you have 3, 2, and 1. Okay, so you have 1 over here. Then you can write that as y3 equivalent to 1 times 2. Get 2. Okay, so we go and check again for k equal to 4. Just for the sake of checking, is it the value 0? Okay, because right now, just now when you check at k equal to minus 1, you get the value is 0 over here. So we are going to check that. So at k equal to 4, you have 4, 3, 2. Okay, so you can see that there is no all overlapping value 2, 3, 4 with this value. So you can directly write there y4 equal to 0. Okay, so based on this, you are going to draw out the signal. Okay, signal y. Don't have space right now, but I'm going to draw it here. Okay, so we are going to draw out yn. So you have the value just now, you wrote out from k minus 1. So minus 1, 0, 1, 2, until 4, right? You check it until 4. Okay, so now you already have the answer. The answer just now is at 0, 0 0.5, 2.5, 2.5, 2, and 0. So just got that value. So at minus 0 is 0. At k equal to 0, you have 0 0.5. K equal to 1, you have 2.5. K equal to 2, you have 0.5. K equal to 3, you have 2. And k equal to 4, you have 0. So reason why just now, we check also for k equal to minus 1 and 4. Is that to confirm that after the value of 0, before 0 and after 3, there is no value of yn. Okay, that's why we need to check. Okay, so if you see here method 1 and method 2, okay, we have the same answer. Just that it looks like method 2 has a much complex way to answer it, but actually method 2 it will be a much simpler way to answer the question if you have a complex equation later on. If you have a simple equation like this, it's very easy for method 1, but if you have a very complex equation, you have a RAM signal and so on. So this method one will not be too simple. So understood? Okay, if no question, any question before we take a break? Any question before we take a break and do this exercise? So while we take a break, 10-minute break, okay, for toilet break. So do this one exercise, convolution sum. You're given these two signals, x and intuition. So prove your answer using the two method 1 and 2. Okay. So if there is no question, so I assume that everybody understood. So take 5 and take 5. Okay, 10. So we come back and now it's 9 p.m. Okay, so we come back at 9:20. Okay, 9:20. Right? That be all. And if you answer, okay, in Padlet, if you go to Padlet, you can upload your answer here and later we will discuss for exercise 1. All right, take 5. Thank you. Okay, you're back. Right. I just want to explain reason why method 1 and method 2 is I also explained here for convolution sum because of for the convolution integral you only have one method, which is using method 2, using the graphical method. So this is the reason why you need to also understood on the method 2, because for summation integral we are going to use method 2. Method 1 it's impossible to use because we need to derive everything. Okay, so back again to this question just now. We were doing this question, so I just want to elaborate more on how you get this x minus 1. Okay, so x minus 1 here is that you have the overlapping area, okay, at this value 0, minus 1 and minus 2. Okay, if I were to draw it in this one same graph, this one is the magenta color is the xn, okay, xn. So I have xn magenta, so sk lah, I write that sk, one magenta. So I'm going to write for the h, for hk. So hk is that we have the value at this point, okay, minus 1, minus 2, minus 3, and we have 1. So minus 1, minus 2, minus 3, we have 1. Okay, so by drawing it in one graph like this, you can see that actually signal h and minus k does not actually overlap with the xt. That's why you get a 0. Okay, and for x, for k equal to 0, okay, k equal to 0, we are going to refer to this value here. So you have at minus 2, minus 1, and 0. So you have minus 2, you have 1, at minus 1, and here 1. So directly, if you draw it like this, you can see that it's only one value that is overlapping, which is at k equal to 0. So you can directly 1 times 0.5, and you get 0.5. Okay, and so on. So if we were to do for y 1, so you have at minus 1, 1, and 1. Okay, so you see that there is only two value which is overlapping at k value at this 0 and 1. So you have 1 times 0.5, so 0.5 plus 2. So you have 2.5. So this one, after doing one of the value, then you can actually estimate directly. So next is 0, 1, 2. So 0, 1, 2, you have 1, 1, and 1. So there are two value overlapping. So you have 0.5 plus 2. So you get 2.5. Okay, next is x at 3. You have 1 and 2 and 3. So you have at 1, 2, and 3. So the overlapping value is only at 1. So you have 1 times 2, you have 2. At y4, you have at 2, 3, 4. So 2, 3, and 4. So there is no value overlapping, so you get 0. So after doing all this, then only you write out the equation for yn. Okay. So yn, as mentioned just now, similarly, you draw it out at minus 1, since you already calculate at minus 1 here. 1, 0, 2, 3, 4. So you have 0, 0.5, 2.5, 0.5, 2, and at 0. Okay, so there is one way how to check it. Is my answer correct? Is my yn correct? Okay, maybe the value sometimes you miscalculate it using calculator or when you calculate it. But you can actually check if this number of impulses is correct. So how to check is that by using this equation. To check it is that the length of yn is equivalent to length of xn plus length of hn minus y. Okay, length. So meaning that from this question is that you know the length of xn is what? How many impulses we have? 2, right? So 2 plus length of hn, we have 3 minus 1. So you have 4. Okay, so you see that this 4 value, you can see that you only have 4 impulses. So directly, oh, okay, when you calculate this one, you can directly use the very fast checking that you get the correct answer. Okay, so I would need to emphasize that method 2 is also important here for convolutional sum, because the same method will be used for the convolution integral. So if you don't understand the concept, then you might struggle for the convolution integral later on. Okay, so we actually take a break on exercise 1 just now. So exercise 1, okay, I saw that Haikal. Let's look at your answer. Is it correct? Okay, it looks correct. Looks correct, eh? Okay, very good, Haikal. Okay, how about the rest? Haikal just orang. Okay, so Haikal did the question. So I'm sure if Haikal are able to answer that, then you guys also able to answer it. Eh? So I think I'm going to skip this since I'm sure you guys can do it on your own for this exercise 1. Okay. Exercise 2, okay, a bit difficult. If you see here, exercise 1, okay, you have to signal xn, which n. Okay. Let's look at the chat. I want to see the 10-minute break. What did you do actually? Haikal managed to finish the exercise 1. How about the other student?
Madam, we are all stuck at method 2.
Oh, you're stuck at method 2.
Yeah, madam.
That you guys have problem now at method 2. Okay, then
Yeah,
I
madam.
assume I assume that method 1 you can just simply use the equation just now. So I will explain method 2 now. Okay, so method 2. I think I'm going to use the whiteboard because it's too small. Yeah. Okay, let's look at the question. Okay, you have two signal xn and hn. So you are going to use method number 2. Okay, so based on this two signal, which one do you think is the much simpler signal? Signal xn or hn?
And
Hn is much more simpler. Okay, so by doing that, sorry, I'm going to write the equation. So equation is that yn equivalent to summation. Okay, so if you know that the much simpler equation is hn, so it means that this hn is the one that we are going to do the shifting. So what you need to do is that you are going to actually do all the shifting here to convert the hn into hn minus e. So the one that we are going to fix is xn. So xn will be the value here. So x xk multiplied by h and minus k. So we are going to use this. Okay, this equation. So start with similarly start drawing out what is the fixed value. So fixed, we are going to fix this. Okay, so fix that value. So you have 0, 1, 2, 3. Okay, you have it at 1, 2, and 3. So this is value n. We already changed it to k. So k. Right? So this one and this one is x k. Now we are going to draw out this hn. So we're going to shift it. So how to do that is that write it hn, and then we are going to make it times k time reversal hn minus k. Okay, so basically whatever you have here, the value you're going to reverse it. So 0, minus 1, minus 2. Okay, so I'm going to directly eyeball that. So you have here n minus 1, n minus 2. Okay, if you want n minus 3, if you want to put there. Okay, so the value for 0 is this one. And n minus 1 is 2. N minus 2 is 3. Of course, here is 0. Right? Okay. So this one will be n minus k. Okay, now to make sorry. It's what? Change the font. Yeah, I'm going to write that out. Okay, you have the k value. Okay, remember just now, when we start with the equation is that we want to test it out. We have the fixed value here, xk. So you may want to write it as this, as 0, 1, 2, 3. Okay, we have 1, 2, 3. So this one is xk. Okay. So by having that is that now we want to find the k value where there is no overlapping. Okay, so if there is overlapping means that you're going to start with the value k0 here, right? So k0. Okay, so let's say that is k minus 1. So k minus 1 means that you have minus 1, minus 2, minus 3. Okay, so at k minus 1, if you were to draw this out over here, so you have minus 1, minus 2, minus 3. Okay, you have 3, 2, 1. So there is no overlapping, right? So y minus 1 is equal to 0. Okay, so bit easy. So I'm going to just use that. Oh, 0, 1, 0, 1, 0. Okay, so this one is good. Okay, so now let's go to k equal to 0. So k equal to 0, 0 minus 1 minus 2. So 0, we have 0 here. So 0 is what value? 1, right? At this 0, so we have 1. So you have 1 overlapping that. Then you have minus 1, 2, and 3. So the overlapping value is only at 0. So you can directly write it y0 is equivalent to 1 times 1, right? So 1. Okay. K equal to 1. So you have 1. You have 1 minus 1 minus, sorry. Is that correct? 1, 0, and minus 1. Okay. So for k equal to 1, we have n equal to 1, n minus 1, 1 minus 1, 0, 1 minus 2, minus 1. So we have minus 1, 0, and 1, right? So we have 3, 2, and 1. Okay, so you can see that you have y1 is equivalent to 2 times 1, 2 plus 2 times 1, 2. Get 4. So now you already have 3 value. So calculate that. K equal to 2, K equal to 4, okay, sorry. K equal to 3 until K equal to, if according to my calculation, you will get until K equal to 5. Okay, so K equal to 5. I'm going to just write it simply. I'm not going to draw this out. You can do it on your own. So I'm going to just write here. So put K equal to 2, you have Y2. Okay, Y2, you have 2, 1, and 0. So you see that at 2, 1, and 0, which one is overlapping with this value? So you have 2 and 1 and 0. Okay, so you have 3 at 0 here, 3 times 1, 3 plus 2 times 2, 4 plus 1 times 2. So you have, okay, next K equal to 3, Y3 equivalent to, so continue here, Y equal to 3, so 3, 2, 1. So which one that is overlapping here with the XK? So you have 3, 2, and 1. This one, eh? So everything is overlapping. So right, 2 times 3, 6 plus 2 times 2, 4 plus 3 times 1. So you have 13. Okay. Next is going to write here K equal to 4. So you have Y4. Okay, Y4, 4, 3, 2. Okay, 4, 3, 2. Which one is overlapping? So you have 2 and 3 here. So this one, 2 and 3. So you have 2 and 2. 3 times 2, 6 plus 2 times 3, 6. You have 12. And K, you have 5. At K equal to 5, you have 5, 4, 3. So which one is overlapping? Only 3. Okay, so 3 times 2. 5 equal to 9. Okay. And of course, you must check whether or not are there any other overlapping area. So example just now, you check from y minus 1 is 0. So you must check again until you get a 0 value for yn. So we are going to check if 6, K equal to 6, you get 0. So K equal to 6. So you have 6, 5, 4. Of course, there's no overlapping. So that's why you will get K equal to 6, y 6 is 0. So from here is that you can draw out your signal yn. So you have from minus 1, 1, 0, 1, 2, 3, 4, 5, 6, because we calculate from minus 1 until 6 just now. So just plot it. So you have minus 1 is 0. And y equal to 0, you have 1. Y equal to 1, you have 4. Y equal to 2, you have 9. Y equal to 3, you have 13. Y equal to 4, you have 12. Y equal to 5, you have 9. And then 6, you have 0. Right? So this is where you plot your answer into a graph. And this one will be the final answer. Right, guys? So just now, who was asking the question? Understood? Which part did you jam just now?
Again on computing the table. Yeah.
Computing the table, is it? Meaning
Yes.
this one? Okay,
Yeah.
right. You understood how to get that?
Yes.
Okay, all right.
but
Very
need
good.
some time to digest.
Okay, normally for students, actually I explain only this the left side because for me, you can actually match it out together at the value 0, 1, 2, 3, and then which one is matching. But if you get confused, you need to draw out like this, like I explained just now. Means that for y minus 1, you draw it out, then you can see that, oh, okay, there's no overlapping. And y equal to 0, k equal to 0, then you see that, oh, there's one value overlapping. Okay, so you won't actually make mistake if you draw out again for each other value. But if for my case, because I'm already teach so many times, so I find out that if student can actually do this table only without doing this graph, should be okay. If you get the final answer, okay. But if you think that by having this table you get confused, so you need to draw this out. Okay, draw it out for each of the k value. Okay, if I were a student, I would add another column at the side here. Okay, I will write here yn. Okay, then it will be a complete table. So what k equal to minus 1, you get 0, 1, 4, 9, 13, 12, 9, and 0. And from here, actually, you can plot yn. Okay, but if you think that you're going to make mistake when you do without having this graphical over here on the right side, that's why the method 2 is named as graphical interpretation of convolution sum. Okay, because student need to draw out this graph. Okay, but if you do a table, but you still able to draw to come out with the calculation y minus 1, y0, and so on, it's okay. But if you find that you might make mistake, then you need to draw out this graphical. Right. So based on that, I think we don't have time. We already 9:46, and so we already discussed a method. This one, method 2, but method 1 you can just simply add it in the equation. Okay, and let's compare. Is it correct with method 2 just now? Okay. So do this as exercise. Exercise 2, convolution sum. Okay. This exercise 2, please make it's actually a task that you need to submit by midnight, by noon, to choose that. By 12 midnight, tonight midnight. Okay. So the question is the exercise number 2 just now. Okay, exercise number 2, which is this one. Please submit it as a task. Means that if you understood what I explained just now, you'll be able to do it. So prove it using 2 methods, method 1 and method 2, and upload your answer to Google. Okay. And then you can. I think this one is also in the slide that I gave upload in Google. So this one is example of midterm exam. Okay, and it doesn't. If you see here, okay, 2 LDI filter have an impulse response given by H1 and delta n plus 2 minus delta n minus 2, and H2 is given by this value. So we have H1 and H2. Look, see that you can see that you are not given any signals. No signals given. Is that in terms of graphical? Okay, it means that you need to interpret this H1. H1, this is where chapter 1, you need to use chapter 1 knowledge. Means that write out what does H1 signal looks like. Okay, so draw the graph. And then H2, how does it look like? You have the time shifting, you have the unit step shifting over here, plus and then you have the minus with the n minus 4, and then you have the random value. So if you see here, question number A, carefully sketch the function of h1n and h2 over minus 10 and 210. So this one is actually covering chapter 1. Okay, 4 marks. Means that if you get wrong this answer, then it will actually affect to question B. Okay, the question B is that assume that the two systems are connected in parallel as shown in figure 2A. It determines the impulse response yn1 for the parallel system in terms of h1 and h2. So this one is simple. This is exactly what I explained at the beginning here. Okay, this one like this. We have two signal, so yn is signal 1 plus signal 2. So what you need to do is just add each of the amplitude at the k value. Okay, so and then plot yn. Right. So this one is still chapter 1. Okay, just add the two signal. Okay, now we want to see the question C. Assume that the two systems are connected in cascade. Okay, you are given two systems, H1 and H2, connected in cascade. So just now, it's like what I explained just now. Oh, okay, cascade. And then these two are signals. Okay, signals. It's not a value, it's not a gain value, it's a signal. There are multiple impulses inside there. Okay, so determine the impulse response y to n for the cascade in terms of h1n and h2n. Okay, so basically what it asks is that you want to find the cascade for the impulse response. Okay, so if this were to be drawn again, so you have xn, y2n. The y2n is actually h1 convolved with h2. So, and then since it's discrete time, you know that you are going to use convolution sum. Okay, so convolution sum. So from there, you do the convolution sum based on the signal that you drawn in A. Okay, so this one is example of midterm. Okay, means that if the first signal is sketched wrongly, means that it's chapter 1, you do not understand how to plot a RAM value, okay, unit step value, shifted, and so on. Then you will have trouble to answer for C value, which is in chapter 2. Okay, so please remember, okay, signal system is not something that you can do last minute revision. You need to understand the process. If you do not understand, then you can ask questions like some of the students just now. Okay, you directly understood the contents. Okay, I think that will be all. Okay, so we have done this 2.1 and 2.2. So next week we'll be continuing the convolution integral, which is on the continuous time. So for the example midterm, make sure that you I do not actually ask compulsory to answer that, but you can try to do it on your own, and we will discuss it later on, maybe before the midterm exam. Okay, and we will have few example other than this example. We have few example to discuss. Tomorrow, actually in Malacca is a public holiday. Is Malacca Bandara Sejarah holiday. So I cannot make the class. So because it's actually according to ISO, we cannot make class during public holiday. So tomorrow no class. So the end task is just for students to submit the exercise 2 convolution. Okay. Any question? Okay, I have gone through the attendance. Those who have not done attendance, please do so immediately. You only have 7 more minutes before the attendance is closed at 10. Okay, present today is 52 students. Let me see in WebEx how many students are inside. 52, okay? Okay, so everybody is in. And then don't forget, you can please do the revision, the reflection class. Okay, do it now. You have roughly about 5 minutes. So do that. If you don't have any question, then that will be all for class today. So thank you very much, and to all Muslims, selamat berpuasa. Okay, that's all. Assalamualaikum very much.
Thank you, Doktor. Selamat puasa.
Terima kasih doktor.
Okay, sama. Alright, bye-bye guys.